Today we are going to be talking about scientific notation. So when is scientific notation actually used in the real world? So we actually use it with either some very large numbers or very small numbers. A lot of the times you'll see the large numbers when we're talking about space. A lot of the smaller numbers are when we're talking about like some anatomy or some chemistry, or when we're talking about bacteria and microbes. For larger numbers, you'll see algebraically it's written like this, but where you have a number and you're multiplying it by 10 raised to a power, and this is a positive power. On the other hand, if for smaller numbers, it's raised to the negative power. Now we have some numbers. We have some large numbers and we have some small numbers. What we want to do is put it in scientific notation. So I am going to do these first two, and then you're going to do the next two. So the first step is you have to find where the decimal point is. So currently, the decimal point is right here. Now when we want to put it in scientific notation, the first number that we always put has to be between 1 and 10. So with this number, we have to make a number that is between 1 and 10. I'm going to put a decimal point right here. If I put the decimal point between the 2 and the 0, that makes a number that's between 1 and 10. So what I'm going to do now, I'm going to write down every number in here that does not include all of these zeros. So I'm going to write down 2.01, because if you realize these numbers, so I have the 2, that's a non-zero number, here's a 0, but right after that is a 1, so I have to include this 1. Now, it's always times 10 to the something to figure that out. Start at this decimal point. We're going to see how many spaces it takes to move to this decimal point. So we have 1, 2, 3, 4, 5, 6, 7, 8. It takes 8 moves to get to that decimal point, so we put it as an 8. So the scientific notation would be 2.01, or 2 1/100ths times 10 to the 8th. Now we're going to do the same thing down here at the bottom. I'm going to put the decimal point in between the 5 and the 1, because remember that the number has to be between 1 and 10. So from this decimal point, how many spots does it take to move to the left, to the other decimal point? So 1, 2, 3, 4, 5. So I got 5.1. It's always times 10 to the, and it was 1, 2, 3, 4, 5. Now, since it's moving to the left, it is a negative 5. Thus, this is smaller. So what I want you to do is to try the 2 off to the right. Pause the video and unpause it when you're ready to see what I've done. Alright, so now I have the decimal point. I'm going to put the decimal point started off here. I'm going to put a decimal point between the 7 and the 6. So I'm going to write those down, 7.6, and I know it has to be times 10 to the something, and it goes 1, 2, 3, 4. This will be times 10 to the 4th. The second one down here, remember I have to make it between 1 and 10, so I'm going to put the decimal point in between this 1, and so it would be 1.02. Has to be times 10 to the something. Move from this decimal point over to here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it'll be a negative 10 since we moved it to the left. Now we have some numbers that are in scientific notation, but I want to make it to be standard form. This is fairly simple as well. I'm going to do the first 2 on the left, and you're going to do the 2 on the right. So if it's 6.23 times 10 to the 7th, what we do, start at this decimal point. We know since it's a positive number, it's going to be a large number. So all that you do, from this decimal point, you're going to move over 7 spots. So I'll show you. So if it's 6, 2, 3, I know the decimal point is right here. So I'm going to move over 7 spots. So it'll be 1, 2, 3, 4, 5, 6, 7. With this, where these gaps are, just plug in zeros. And this is our number. It is 62,300,000. Right now, so it's 1 off to the left. Now look, we have a negative sign. So if we have a negative sign, we're going to move the numbers to the left. So if I write the number out first, and I know the decimal point is right here, and I have to move it 8 spots to the left. So decimal point's here. 1, 2, 3, 4, 5, 6, 7, 8. Plug in zeros. Decimal point is there. And this is your number. So what I want you to do, pause the video, try these 2 off to the right, unpause it when you're ready to see what I've done. Alright, so the top one, we have 4.29 times 10 to the second. I'm going to write out the numbers. I have the decimal point, which is right here, and I have to move it 2 spaces to the right because it's positive. So if I move the decimal point here, 1, 2, I don't even have to add any zeros because it stops right there. So the number that we have is 429. Now the second one, I have the decimal point right here. I have to move it 4 spaces to the left because of the negative sign. So 1, 2, 3, 4. And this is our answer. So it's 0.000123. Now we're going to be multiplying some scientific notation. So these look kind of daunting, where it's 4.2 times 10 to the 6 times the quantity of 2 times 10 to the negative third. But just remember, just take it easy, just break it out. So if we have, let's take the whole numbers. Let's just do 4.2 times 2. We know that is going to be equal to 8.4. Next, we know how to multiply numbers that are raised to a power. So what is 10 to the 6 times 10 to the negative third? When we do that, all we have to do is add them together. So what is 6 plus a negative 3? That would be 10 to the third. Now all we have to do is combine it. So we have 8.4 times 10 to the third, because I took the 8.4 from here because we multiplied these, and then I took the 10 to the third from here because we multiplied those. So now we have 8.4 times 10 to the third. Now I want to see what it is in standard form. So I'm going to write it like this. Decimal point is here, so the decimal point is here. Move it 3 places to the right. 1, 2, 3. Add the zeros. So our answer is 8,400. So what I want you to do, pause the video, try this one at the bottom, unpause it when you're ready to see what I've done. Alright. So I'm going to break out the numbers. So that is 6.5 times 2. That's 13. Now if we have 10 to the 10th times 10 to the negative 15th, when we do that, we're basically doing 10 times 10 plus a negative 15, which is the same as 10 to the negative 5th. Now we're going to write these. So we have 13. But the decimal point is right here. This is the tricky part. I need it to be between 1 and 10 for scientific notation. So I have to move this decimal point over to the left. By doing that, I have to take away one of the powers up here. So this is going to turn into 10 to the negative 4th, because I've already moved 1 over. Now, I treat it just the same, 10 to the negative 4th. Go 1, 2, 3, 4, add the zeros, and this would be our answer. So 0.00013 would be our final answer. So we did some multiplying, now let's do some dividing. It's basically the same exact thing. We're going to break out the numbers by themselves, and then when we're dividing numbers that are raised to a power, remember, we have to subtract the powers. So with this, I'm going to break it out as 2.3958 divided by 1.98. That is equal to 1.21. Now if we have 10 to the 3rd divided by 10 to the 8th, remember that's basically like 10 to the 3rd minus 8, which is equal to 10 to the negative 5th. Now we have 1.21 times 10 to the negative 5th. By doing that, since we have a negative 5, start this decimal point, move over 5 spaces to the left. From here, 5 left. 1, 2, 3, 4, 5. 0, 0, 0, 0. So this is our final answer. So it's 1, 2, 3, 4, 1, 2, 1. That's our final answer. So what I want you to do is to pause the video, try this one off to the right, and unpause the video when you're ready to see what I have done. Alright, so I'm going to break out the whole numbers. Which is 42 hundredths. Now I'm going to break out the tens. So it's 10 to the 8th divided by 10 to the 3rd, which is basically 10 raised to the 8 minus 3, which is 10 to the 5th. Now we have 0.42 times 10 to the 5th. But if you realize, this needs to be between 1 and 0. So I'm going to move this over. So it would be 4.2 times 10 to the 4th. Because I have to take one of these away when we move the decimal point over to the right. So now we have 4.2 times 10 to the 4th. We solve it from there. Remember we have the 4th, so 4 to the right, 1, 2, 3, 4, 0, 0, 0. So our final answer is 42,000. Time for a quick review. Remember when we were talking about scientific notation, our answers, if we're saying scientific notation, the number must be between 1 and 10. When we're moving it from scientific notation into standard form, we have to move the decimal point however many digits the exponent says. If it's 10 to the n, which is a positive number, it's going to be a large number. If it's to the negative n, it is going to be the smaller number. So remember to look down my comments for different videos that might help you if you're struggling with this. Let me know if you have any questions. I think you all are going to do fine.